Well, hello and welcome to the first section of this. We have to find the magnitude of these to get the dot product, because we know dot product is going to give us a scalar, and we have unit vectors. Which unit vectors is not going to do anything, because unit vectors have a very different symbol. As you can see, have like an x hat, y hat, z hat. They're going to have like a hat on top of them, so we cannot use numbers to represent them. So you have to get it to the scalar, a number, and then get it to dot product. So we're going to use x and y and z hat, and we're going to use our knowledge of, okay, how am I supposed to get this to a scalar? I'm going to use the magnitude from the components. I'm going to get square root of 45 for the a, because I'm using all the components for that. I'm going to use all the components for the b that I have, bravo. Alpha is going to be square root of 45. It's going to be 2 on square root of bravo, because actually no. No. This is going to be square root of 6. I cannot get a 2 out of that. This one goes to square root of 3. Yeah, okay, that's my bad on my part. It's going to be square root of 3. Yeah, so we're going to get all our components, and now we have to find out from dot product whether we're going to get an acute dot product or not, because they asked us to get a positive. So let's see if we can get a positive or not. And again, remember that the things that we have for components, we're going to just square them and then square root of them to get the angles that we have, vectors that we have. Now that we try to get the dot product from the components, because we make it into magnitude, now that we get a magnitude, we can go ahead and see that we have the Cartesian coordinate system again, x hat, y hat, z hat. Although I have a lot of them for having the z hat, I tried to find out which two vectors would work. Although one of the two worst one I didn't want, it actually worked out to be an acute angle, because other vectors that I tried to find out, they didn't give me an acute angle. So vector E is gonna go negative 4x hat and then 10y hat to the top, which I draw that, and the vector F is just going a little z hat towards down, pushing up, and then 5y hat up. Even though we have a z hat and we don't have a z hat for E, we're still gonna have less than a 90 degrees angle between them. To me, it's at 30 degrees, because E is gonna be very close to F, but just having a lot of height. So that's the thing I see between F and E. So I'm gonna say they have a 30 degrees angle between them, and then we're gonna put this to work and say, okay, square root of 116 times the square root of 26, because we get the magnitude from the components on that part, and then times cosine of 30, which we're gonna get 47.56. And remember, acute dot product is gonna have a positive dot product, so acute angle is gonna have acute angles are gonna give us the positive dot product. So that's how we can get the positive and find out, okay, that's right, because we have the Cartesian coordinate system, which is x, y, z hat, are perpendicular. So you're gonna have those on E and F, and then after we got that, we're gonna get the magnitude times the cosine of the angles between them, and using that we can get the dot product, which gives us a scalar. And remember, we all have a scalar, because dot product we cannot use a unit vector on it. So we get a scalar which is positive, and that's gonna give us a correct answer of having this dot product. So hopefully you guys learned something new, and I see you guys in next videos, and hopefully you guys make a comment if you have any questions.